Welcome to the deep dive. Today, we're really jumping into the world of statistics.
Yeah, it's absolutely vital these days, isn't it?
Totally. With data just everywhere, knowing the basics is key. So, our mission is, well, to unpack the core ideas from our sources, see how stats helps make sense of it all.
Makes sense. We'll look at why it's so important now, some methods, different kinds of data,
Yeah.
the works.
Exactly. So, why has statistics become such a big deal recently?
Well, there's been this meteoric growth, really,
Mm.
driven by a few key things. First, just the explosion of data.
Right. The internet, social media, phones, it's
Yeah.
constant.
Precisely. Think about Walmart. They handle over 1 million purchase transactions per hour. Or Facebook with, what, 250 million picture uploads daily?
Wow. That's a lot.
It is. That's big data. We talk about volume, obviously, but also velocity, how fast it comes in, variety of different types, and value and veracity, too. You need stats to sift through that.
To find the actual insights, yeah. Improve profits, understand customers.
Exactly. And the second driver, huge advances in computing power.
So we can actually process all that data now.
We can. Plus, we have much more sophisticated algorithms, better data visualization. It all feeds into business intelligence, AI.
Okay, so more data and better tools to analyze it. What else?
The third piece is storage. We
Mhm.
can now store massive amounts of data, and things like parallel and cloud computing mean we solve big problems way faster.
Got it. Data, power, storage. So with all that, what can we actually do with statistics? What are the methods?
Okay, good question. One big one is classification. Basically, sorting things into groups.
Like segmenting customers, maybe long-term ones versus brand switchers.
Exactly like that.
Yeah.
Or just buyers versus non-buyers. Helps you understand behavior, position products.
Makes sense. Tailor the approach. What's another method?
Pattern recognition,
Hmm.
often very visual. Think histograms showing income distribution. Is it symmetrical? Is it skewed?
Or box plots. I know they're good for spotting outlier.
Right. Or scatter plots to see if there's a relationship between, say, age and how much someone spends. You spot things you wouldn't otherwise.
Okay, visualizing patterns. Cool. What else?
Association. This is about finding relationships between items. The classic example is market basket analysis.
The people who buy diapers also buy beer thing. Although maybe coffee and bread is more common.
Yeah, maybe. Like finding coffee and bread are bought together with a 40% probability. That's gold for store layout or suggesting related products online.
Cross-selling, right. And the last method.
Predictive modeling. Using data to predict future outcomes. Regression is a common one. Maybe you're predicting expenditure based on income, age, gender,
So forecasting.
forecasting, or even classification for prediction. Using models like logistic regression or neural networks to predict if someone will be a buyer or not, or maybe default on a loan.
Okay, so those are some powerful tools. But let's back up. How do we even define statistics formally?
Well, there's a classical definition from Ewell and Kendall. They called it methods specially adopted to the elucidation of quantitative data affected to a marked extent by the multiplicity of causes.
Bit of a mouthful. But it emphasizes quantitative data and multiple causes. How does that compare to something like business analytics?
It's interesting, actually. Thomas Davenport defined business analytics as the broad use of data and quantitative analysis for decision-making within organizations. Very similar focus on data analysis and making decisions.
So different eras, similar core ideas. Now, are there different types of statistics?
Broadly, yes.
Yeah.
We usually talk about descriptive and inferential statistics.
Okay, what's the difference?
Descriptive is about summarizing the data you have.
Yeah.
Graphs, charts, tables, averages. Just describing what's there.
Giving you the snapshot.
Exactly. Inferential statistics is where you use a smaller group, a sample, to draw conclusions about a much larger group, the population.
Okay, let's break that down. Population is everything.
Pretty much. The whole universe of possible data you're interested in, maybe all visitors to your website. A parameter is a numerical value describing that population, like the true average time spent on the site by all visitors.
Which you might never know exactly.
Right. So take a sample, maybe visitors on one specific day, and a statistic is a value calculated from that sample, like the average time spent by those visitors on that day.
And you use the statistic from the sample to infer something about the parameter of the population.
You got it. That's inferential statistics in a nutshell.
Okay. Where does all this data come from in the first place?
Two main sources, primary and secondary.
Where primary is.
Data you collect yourself directly for your specific purpose. It fits your needs, it's up to date, generally reliable because you control the collection.
Makes sense. And secondary.
That's data collected by someone else, probably for a different reason. Think published reports, academic studies, government data, stuff you find on the web or social media.
Right, it already exists, you're just using it. Okay, and the data itself comes in different flavors too, right?
Yep, big distinction. Qualitative versus quantitative.
Qualitative is non-numeric, like gender, maybe place of birth.
Exactly. Categories, descriptions. Quantitative is numeric, bank balance, number of kids.
And quantitative can be split further.
It can. Into discrete and continuous. Discrete data can only take specific values, usually whole numbers, with gaps in between, like the number of rooms in a hotel.
You can have 2.5 rooms.
Right. Continuous data can take any value within a given range. Think production quantity in kilograms. It could be 10.5 kilograms, 10.52 kilograms, and so on.
Okay, clear. Our sources also mention different types of data sets quickly, like records, graphs, ordered data.
Yeah, the structure can vary a lot. But fundamentally, data sets are made of data objects, the things being described, like customers or patients.
And these objects have attributes?
Attributes, yes. Also called dimensions, features, variables. They describe the objects. Customer ID, name, address. Those are attributes.
And these attributes have types too.
They do. We can talk about nominal attributes categories with no real order, like hair color or marital status.
Just labels.
Pretty much. Then binary attributes, only two states, like gender or maybe a medical test result, positive, negative, often coded 0 or 1.
Okay, what's next?
Ordinal attributes. These do have a meaningful order, but the difference between the values isn't necessarily equal or known. Think sizes small, medium, large, or grades.
You know, large is bigger than medium, but not how much bigger.
Precisely. And finally, we have numeric attributes, which are quantitative. These split again.
Ah, like quantitative data itself.
Kind of. We have interval-scaled attributes. These have order and equal intervals between values, but no true 0 point. Temperature in Celsius or Fahrenheit is a classic example. Or calendar dates.
0 degrees Celsius isn't no temperature.
Right. The last type is ratio-scaled. These have order, equal intervals, and a true 0 point. This means ratios make sense. Temperature in Kelvin, length, counts, money 0 means none, and $20 is twice as much as $10.
Okay, that covers a lot. So we've seen why statistics exploded, the methods like classification and prediction, descriptive versus inferential, data sources, types, and now the attributes that make up data sets.
It really paints a picture of statistics as this essential framework for understanding the data-rich world they're in. You need these concepts to make sense of it all.
Absolutely. So wrapping this up, here's a thought. Considering the sheer amount of data and these powerful statistical tools, what's an unexpected area, maybe something totally outside the usual business or science boxes, where you think statistical analysis could lead to some really surprising breakthroughs in the future? Something for you all to ponder. Thanks for taking this deep dive with us.